everything that we have learned in Newton is leading us up to inclined planes. All right, this is as hard as it gets for this unit, so try to follow along. Here we go. We have a 2 kilogram mass. It's going to slide down an inclined plane at an angle of 30 degrees. And we also have a mu coefficient value that's going to be equal to 0.2. All right, there are 6 steps to solve this problem. Don't worry. First one, we're going to tilt our axis. So here, in a normal world, this would be a flat axis. But for solving these problems, it's much easier just to tilt it along with whatever angle you have so that all of your directions and components all line up in the perfectly horizontal and vertical plane. All right, step 2 is the law of alternate interior angles. So for this, what we're saying is that if we look at the 2 kilogram block, the force of gravity goes straight down. And we are going to find 2 components. We are going to find this component, which is equal to the normal force, and this component, which is equal to the force of gravity in the x plane. And it turns out that this angle, 30 degrees, is the same as this angle of 30 degrees for theta. So I know that this angle and this angle are the same. So step 3, well, now we'll start writing our steps out because we're actually going to start doing some math. The first 2 were just set up ideas. So step 3, we're going to solve for the normal force and the force of gravity. Solve F sub g sub x and normal force. All right, if I look at my triangle that I've created, I have an angle here. I know this red component because that's the force of gravity. So if it has a mass of 2 kilograms and acceleration due to gravity is 10 meters per second squared, this has a value of 20 newtons. So let's look at solving for the normal force first. That is going to be this blue arrow here, which comes down at an angle. Since we're tilting our axis, it is going to be completely upward. So here I'm looking for the adjacent. I have the hypotenuse. So normal force, always, 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 is just going to be mg, whatever the mass is, times gravity, times the cosine of theta. And the force of gravity in the x is always, always, always going to be mg sine theta. And when we solve for both of those values, we get the normal force, or we'll just write it out. So 20 times the cosine of 30 degrees, 17.32, and here 20 sine of 30 degrees, 10. And both of these are just newtons. All right. Now, step 4 is I need to solve for the friction force. So step 4, solve friction force. Well, what's my equation for the friction force? Friction force equals mu times the normal force. Mu is given. And I just solve for the normal force over here. So friction force equals 17.32 times 0.22, which gives me an answer somewhere in the neighborhood of 3.5 newtons. 3.46, whatever, 3.5. All right. Step number 5 is solve for the net force. Solve for sigma f. Now, F sub g sub x is what's moving us down the incline, and the friction force So F sub g sub x is moving us down, and the friction force is moving us back. So the net force is equal to F sub g sub x minus the friction force. So here's S sub g sub x. Here's the friction force. So 10 newtons minus 3.5 newtons equals, that's right, 6.5 newtons. All right, almost there. Step 6, solve for acceleration. Well, Newton's second law, sigma F equals ma. I rearrange. A equals the net force divided by the mass. Net force, 6.5 newtons, divided by 2 kilograms, gives me an answer of 3.25 meters per second squared. Boom, and I circled my answer. And that's how it's done.